Okay, make sure the screen is visible and I'm audible. And if it is so, let me know in the chat box. Write yes in the chat box if it both the things are okay to you, my voice and the screen. And then we will have the session. Okay, Roshan, thank you for clarification. Okay, guys. Okay. So, in the recent chapter or the recent lecture, we have covered gravitation. So, gravitation we have already covered. Okay. So, this is a very fresh chapter to you. This is mechanical properties of solid. It is also a kind of energy capsules. Okay, it is one of the chapter named as energy capsules because this is a very short term chapter. But if you get one or two questions from this chapter, that it would be very wonderful because ये जो chapter है ना, just a second, very small portion of this chapter, very small, and syllabus is also reduced. ठीक है, प्रीवियस जो सिलेबस था वो थोड़ा ज्यादा था, अब तो उससे भी कम हो गया है. Got it? From the recent syllabus, if you will see, most of the portion of this topic has been removed from your JEE main syllabus. So for now, very less syllabus for this chapter, and one or two question if came from this topic, it would be like a win-win situation for you. Got it? So this chapter name is mechanical properties of solid. After that, we will be studying the mechanical properties of fluids. Okay. So in today's lecture, what we are going to cover is what is elasticity first of all, some basic terms related to elasticity. Why is this phenomena arise? We will understand that. Then stresses and its type. I know that most of you guys will take some stress. Everybody are very much aware about this term stress. Then we will understand that what is the significance of this stress in the physics, and what type of stress exactly we have. Then we will move to the strain. Strain is nothing but the whatever the effect of a stress can bring, that effect is measured in terms of strain. So as many types of stress we have, same type of strain we would have, because if number of stress like 4 or 5, so they will produce different types of strain. Okay, so same number of strain would be there. Got it? So let's just start. What is elasticity first of all? देखो, in the previous chapter we have covered center of mass, we have covered rigid body dynamics. In those chapter we have seen the object that we used to study, to solve a question or to derive any formula. We always assume that that particular object or that particular system is rigid. And I have introduced the concept of rigidness or concept of rigid body in the latest chapter that we have finished, which is RBD, rigid body dynamics. And I have told you this concept in center of mass chapter also. Okay. So what is a rigid body? Rigid body is that body in which the relative distance between two elements of that particular object or body will not change in any circumstances. So that particular body is rigid body. But at the same time, I have told you that these types of body does not exist. Okay, we do not have any rigid body in future in practical. Okay, so if there is no rigid body, what kind of bodies we have? So at that time also I have told you, and now I'm also going to tell you, we have deformable bodies which can deform, which can change their shapes, which can change their size, which can change their volume based on the circumstances or based on the situation we put them. in. Okay. So in the same way, if we have a rigid body and we have these 2 points, so whatever the forces you are having here, whatever the forces I will apply, whatever the torques I apply, okay, in these types of bodies, whatever the number of forces or number of torque I have applied here, they will not change the distance between any 2 points, okay, relative to any 2 points. Got it? Suppose this is point 1, this is point 2. So the distance between them will not change. Got it? So D will remain constant under the under any situation. Okay. So this particular body is rigid body. Make sure that I am audible to you each and every time so that you will get to know the concept. But in practical world, real body does not exist. There is no such concept of rigid body. Rigid body does not exist. So what kind of bodies we have? Deformable bodies. Deformable. Deform plus able, which are able to deform their self. Okay? Deformable bodies. Now, these deformable bodies are those, our body is also deformable. Okay? The rubber ball that you are used for cricket or tennis, that is also an example of deformable bodies which can deform. If you apply the pressure to that particular ball, it will deform the shape of it. But again, if you recall this example of a tennis ball, you apply the stress, you apply the force to this, you squeeze that ball. Initially, the ball was like this. Then you apply the pressure to this by your hand, and the ball will look like this at that particular instant. But as soon as you remove these forces that you have applied, you will find that ball will regain its shape again. So this regaining of shape after the removal of any forces, this regaining itself is termed as the elasticity. And in simple world, you can understand elasticity is the property of a body which resists the deformation. ठीक है? देखो, in NLM, Newton laws of motion, what we told? We told that we have been told that there is a term inertia. And inertia is that property of body which resists the change of position of that particular body or change the state of that particular body. More is the inertia, more is the resistance to change the state. Coming from rest to motion or motion to rest in both cases. In similar way, we have applied a force to a practical body. We deform it for some extent and then we remove the force. Again, it is regaining its shape, which means as soon as the body recover its shape or the more effort you have to put to deform that body, more elastic that body is. Clear? For example, we have rubber rubber band that girls used to put on the hair to tie the hairs, है ना? So that rubber, if you stretch, it can stretch easily, but as soon as you remove these forces or let it go, it will again come back to the original shape of it. Now this property, how much force you need to put to deform that rubber band, that particular property of a system or a body is termed as elasticity. Okay? More is the elasticity, more is the force that you need to put to deform that body. Suppose there is a spring, and if you want to deform the spring, if you want to deform the spring, and if you want to deform the rubber band, in which you have to put more force. Obviously, we have to put more force in deforming the spring in spite of this rubber band. So to deform the rubber band, we have to apply very less force, which means this particular rubber band or this particular body can't resist too much. But in case of spring, it will resist so much that you need to put a very large force to deform that, which means the elasticity is the property of material itself. Clear? Clear? So now you can read the definition here. The property of matter by virtue of which a body tends to regain its original shape and size after the removal of deforming forces is called elasticity. I think this definition is pretty much clear to you now. For example, this is the picture that I have put on here. This is rubber bands. So, देखो, this particular man or woman, whoever it is trying to deform it, and this deformation is happening because of the property of elasticity. Suppose a matter does not have this property. A matter has zero elastic property, which means if we trying to deform it, it will not deform. Whatever happens to that particular object, it will not deform. It will break. It will change to some other shapes. So which means that we can classify the material based on the elastic property of that particular materials. Okay. You can see here, this is the example of bow and or arrow. So here, this particular string, which is the string of the bow, is stretched when you pull this arrow, and it is stretching because of this elastic property of it. Got it? Now some basic terms के बारे में बात करते हैं. We have to talk about some basic terms. So if we talk about the basic terms related to elasticity, the first one came to picture is deforming force. Deforming force is that external force that we put to change the shape or size of a body, of a deformable body. ठीक है, not a rigid body. क्योंकि rigid body तो change करेगी. Who will change? Deformable bodies or elastic bodies. So external force which try to change the length. अब देखो shape और size कैसे change होगा? Either you will change the length of that particular object, or you change the volume, or you change the surface area of it. ठीक है? Or the shape of it. Clear है? By changing the shape of any material, what you will do? You will deform the particular body, na? So that is why this deforming force is the external force that we try or that we apply on a particular object to change its length, volume, or shape. Or you can simply say to change the size and shape of a particular body. Okay. Now, I have told you that elasticity can also define the types of body that we are using. Based on that, we have these two classifications: perfectly elastic body and plastic body. Now, perfectly elastic bodies, those bodies, by name you can totally understand. We have applied a force, the body deform. When we remove these forces, the body regain its shape. So when the shape or the deformation is completely recovered, that particular bodies are termed as perfectly elastic bodies. Got it? So as you can see in the definition also, the body which perfectly regain its original form or removing the external deforming force. On removing the external deforming force is defined as a perfectly elastic body. So example के लिए quartz is the a nearby example of perfectly elastic body. Otherwise, if you do it very ideal way, there is no perfect elastic body exist. Okay, you can you can diminish the extent of deformation. You can minimize the extent of deformation, but you cannot completely neglect that. Okay, in practical way. Now the second type of body is the opposite of the first. You applied the force, you deform the body, and the body will remain as it is. It is not changing its shape further. It is not regaining its shape further. So that particular body is termed as the plastic bodies. The first is the body that will regain its shape completely is the perfectly elastic body. The body will not gain its shape completely. That body is plastic body. तो आप देख भी सकते हो जैसे ये दिस इज अ कवर, प्लास्टिक कवर, गूगल कवर है इसका. तो अगर मैं इसकी शेप चेंज करूं क्या ये रीगेन कर लेगा? It will break but not regain its shape. Clear? So the body which does not have the property of opposing the deforming force is known as plastic bodies. That is why it is breaking. That is why it is not regaining its shape. Okay. Secondly, you can also say the body which remain in deformed state even after you remove the forces. Okay. That body is also plastic body. Now, what is that factor? We have understood that we are deforming the bodies. We have applied some external force. Now, what is that force which tries to regaining the shape of the body? What is that force? That force is nothing but the internal restoring force of a particular system or a material. Okay? That force lies in the body itself. For example, we have taken a road here. This is a rectangular road, and we have applied a F external force to this particular road. By this application of force, you will clearly imagine that the length of this system will increase. So there is a change in length of the system. Got it? But if this body is elastic, then the change in length completely recover after removal of this external forces. So what will happen here? I'll show you the atomic level view. I'm just zooming out this picture here. Here, if you will see, there are some atoms, positive, negative, full of atoms. So what is happening here? When this external force try to extend the shape, these atoms are also attracted by itself. They are also bound with the force, which is the binding force. Okay? But when this external force try to capture them, try to grab them away from each other, the force will break. This force will weaken up. ये जो force है, internal force, it will what? It will weak, become weak, and then they will, देखो ये ऐसा है, दो एटम से लेते हैं, ये एक एटम है, ये दूसरा एक एटम है, and we have applied the force and they have also bound with each other. ठीक है? We have applied the external force, so the distance between them will increase. Distance between them will increase. But after a certain point of time, what will happen? This type of force which is lies in between them, the interatomic forces, as the distance increases, the interatomic forces increases. Okay? So now the interatomic forces F interatomic will try to increase. It increase at a very slow rate. देखो, we have applied the F external force. It is very quick. We grab the rod and applied the force. It's a very quick process. But the internal reaction by the atom of the body will not generate very quickly. It will take some time. So it will develop very slowly. It will develop slowly. So suppose the external force that we have applied is 100 Newton, but internally, if internal, if I say, it will develop like 0, 10, 30, 50, 80, and 100. And you will find that when this internal force reaches the value of 100 Newton, exactly equals to the external force that we have applied. After that, you cannot elongate that particular material. Case 4, take the example of rubber band. We are not able to stretch the rubber band from a certain limit. And it is happening because the internal forces balance out the external forces that we have applied. Got it? And after removal of this force also, when you remove this external force, this force again, because it is attractive in nature, so this attractive force come into action and they will regain its shape again. So whatever the change in the shape will bring by this external force, same force will be, or the same force will be applied by the internal reactions or the atoms inside the body. And due to that, if you develop the internal reactions, at a certain point of time, this internal reaction balance out the external force that we have applied, and it would be very tough for us to increase that particular value. Okay? When we move further in this chapter, I'll explain you that what happen if our external forces increase from the value of internal force applied, or what happens if the internal forces is not able to reach the external force value. Then what will happen? So some of you might guess it now, but I'll explain it as we proceed in this chapter. So for now, you will remember that this particular deforming forces, or this particular deformation, or the restoration of the deformation, the regaining of shape, regaining of size, is happening because of the internal forces provided by the matter, provided by the material. Okay? Clear? Otherwise, if you will think, if we have applied the external force, we have removed it, where is the forces? Where is force? And why it is regaining its shape if there is no force? It will be a contradictory partner. So that is why this internal forces came into picture. F internal. F internal is always what attractive type of forces, and these forces are interatomic forces. I'll mention here. It is interatomic forces of attraction. If anyone has any kind of doubt, you can ask right now. किसी को कोई doubt है? Any kind of doubt? ठीक है? So as you can see, the second point, at equilibrium, the numerical value of internal restoring force is equals to the external force, not the direction. Direction is always opposite. Okay? So when an external force act on any substance due to the intermolecular forces or interatomic forces, internal resistance is produced in the substance called internal restoring forces. Okay? Clear है? Now we will talk about the stress. Till now, if anyone has any kind of doubt, it is clear to everyone. Yes and no. Message in the chat box. Then we will start this topic, stress. Only Roshan is responding. What about you, Yamparme, JNV, and others? 10 student, 9 to 10 student is here. Nandani, what about you? Vaishnavi, Priyadarshini, Wangtoy, and Bhavna. What about you guys? Is this topic clear to you? Make sure you comment in the chat box as yes, okay? If it is clear, and if anyone any kind of doubt, you can ask. Now we will discuss about the stress. Stress is nothing but like we have deformed the body. Okay, this is the thing we have done to the body. Now, why we are interested in this stress thing when we can calculate the force? So why we are interested in this stress? In spite we can calculate the forces. Force, the calculation of force is easy. Then why we are interested in this stress thing? Because why we want to stress ourselves? Huh? We want to stress ourselves. No, because देखो, suppose I want to calculate what is the internal reaction developed by this rod made of copper. This rod is made of copper and have a cross-sectional area of 10 meter square. Got it? I want to know what is the internal force developed in it, or how much external force do I need to elongate this rod. Okay? In mechanical sector, this is a very usual question, very necessary question, that how much amount of force we need to put to stress this rod at this particular length. Okay? Suppose the length of this rod is now 10 meter and we want to stress this rod to 15 meter. That what amount of force we need to apply? So to calculate that, if I just change the cross section here, now the area is 20 meter per second. So each and every time, what you need to do, you need to calculate the forces again and again. You have to do the calculation again and again. But what if I calculate such a value that only area need to multiply in that value and you will get the external. That particular value is stressful. Okay. So stress is nothing but the internal restoring forces per unit area of cross section of a deformed body. Okay. So what is the force? Not the applied force, the internally developed force. Okay. So for example, in this particular rod, we have applied the external force, but in the calculation of stress, we always put what is the internal reaction developed by this material. Okay. And for some extent, at the equilibrium value, we know this internal force is nothing but equals to the external forces. Okay. So stress is the ratio of internal force per unit area, internal restoring force to the area, or you can say it is the force, internal restoring force per unit area. Okay, of a deformed body. So it will depends on the direction of force as well as the direction of area of application. So it is a tensor. So tensor is not in your syllabus. Tensor is a topic to be learned in bachelor level of physics. So you have that idea about that case in that. क्या देखो वेक्टर और टेंसर में फर्क क्या होता है? व्हाट इज अ वेक्टर? वेक्टर हैज मैग्नीट्यूड, ओके, एंड डायरेक्शन. बट व्हाट इज अ टेंसर? देखो टेंसर इज दैट क्वांटिटी जिसका मैग्नीट्यूड भी फिक्स नहीं होता है और डायरेक्शन भी लगातार चेंज होता है. ठीक है. वी कैन डिराइव वेक्टर फ्रॉम टेंसर इटसेल्फ. ठीक है. सो टेंसर इज अ थ्री डायमेंशनल एनालिसिस ऑफ वेक्टर इटसेल्फ. गॉट इट? क्लियर है? तो जहां जैसे अभी आपके रूम का टेम्परेचर हर जगह क्या है? सेम है. whatever the point you will choose, you will find the same temperature at each and every point, which means temperature is not a tensor quantity. it has a constant value. But suppose the temperature of a room is changing at each and every meter, then what you will say? The magnitude is also changing and the direction is also changing. I am taking the example of temperature. Temperature is a scalar quantity. But suppose there is a vector quantity which has direction and the magnitude is also changing. Okay? So that is why they defined as a tensor. Okay? For now, you just need to know that stresses are tensor. Okay? And I'll show you that how they will depend on the angle of external force that we have applied. Suppose there is a plane. This is a plane. And we have applied the force in this way. This is the F external force. Now, if you resolve this force into two components, let's say F cos theta and F sin theta. So F cos theta is the force perpendicular to this particular area. And what is the definition of stress? Okay. What is the definition of stress? Stress is the force perpendicular developed to that particular cross sectional area. इस क्रॉस सेक्शनल एरिया के जो परपेंडिकुलर फोर्स डेवलप होगा दैट विल इंक्रीज द लेंथ ऑफ इट ना. क्लियर है? सो इसीलिए अगर आप एरिया को मान लिया मैंने एरिया टिल्ट कर दिया एट एन एंगल थीटा, तो ये मेरा एरिया वेक्टर है, ये मेरा एफ एक्सटर्नल वेक्टर है. either you will resolve the f external in the direction of area vector or you will resolve the area vector into the direction of f external. Got it? Clear hai? So SI unit is very clear, Newton per meter square or Newton meter minus 2, and dimensional formula is this. Clear? Now, there are three types of stress that we deal. What are the three types of stress? Three types of stress are longitudinal stress, volumetric stress or volume stress, and third is very important, which is shear stress. Okay, we will understand them one by one, and it depends. देखो, we know that stress depends on how we have applied the force. So based on the application of force, the way to applied force, the way to applying a force, we derive the stresses into three parts. Because different is the way to apply a force, different is the way to develop the internal reaction per unit area. Okay? Internal reaction will affect. In the previous case, if you will see, if in this case you will see, net external force is this, but the only external force that against which the internal reaction is developing is F cos theta. So the amount of force is decreased ultimately. Okay? So that is why our stress depends on the orientation of force that we have applied. And based on that, there are three types of stresses: longitudinal stress, volume stress, and shear stress. Shear stress को एक और नाम भी बोलते हैं इसका, which is tangential stress. Tangential से थोड़ा ज्यादा आसान हो जाता है समझना. Tangential stress. Now, when the stress is normal to the surface of body, ठीक है, what is longitudinal stress? तो जब भी आप जो फोर्स लगा रहे हो, अगर वो क्रॉस सेक्शनल एरिया के परपेंडिकुलर है, if the force applied by you is perpendicular to the cross sectional or area of that particular material, then the stress developed there will be longitudinal stress. Clear? So when the stress is normal to the surface of a body, then it is known as longitudinal stress. ठीक है? तो उसके अगेंस्ट जो स्ट्रेस डेवलप होगा वो भी क्या होगा? लॉन्गिट्यूडनली होगा. तो लॉन्गिट्यूडनल स्ट्रेस का मतलब फोर्स इज परपेंडिकुलर टू द सरफेस एरिया. Got it? Very clear. अब देखो, we can apply the force perpendicular to a cross sectional area. Suppose this, for this example, we can either applying the force like this, we can stretch it like this, okay, or we can apply the force like this, to compress it like this. Got it? If I show you in this here, we can either apply the force perpendicular to the area like this, or we can apply the force perpendicular to the area like this. So this particular force is nothing but elongate the body, elongate the body. But the lower one, this, it's try to compress the body. Got it? So the first one is termed as tensile stress. The longitudinal stress produces due to an increase in length of the body is defined as tensile strength. And second is compressive stress, which developed because of the decrease in length of the body. Okay. So in this example, this particular mass is hanging around. Mg force is applied to this, and due to which a tension force is developed into this string. If you just zoom into the picture of this string, so this tension would be applied like this to each and every end of the string. So it is trying to stretch out. It is trying to elongate the string. Got it? That is why this particular stress developed at this point is tensile stress. Either you can see the example of this. This force is trying to increase the length of the body by delta L. And if this is a cylinder of length L, we have applied a force perpendicular to the body, which means it's classified the first condition. It passes out the first condition. For longitudinal stress, force must be perpendicular to the surface area. But it is in compressive, it is trying to compress the body. So that is why this particular force produces a compressive stress into the body. Got it? Now, what is a volumetric stress or volume stress? So there is nothing much different about this volumetric stress. If equal normal forces are applied every one surface of the body, then it undergoes change in volume. Okay? The force opposing this change in volume per unit area is defined as volume stress. For example, we have this sphere. We have this sphere, and suppose a force is always perpendicular to the surface. So as you can see here, this particular force is always perpendicular to the surface. It's always perpendicular to the surface, which means ultimately it is trying to compress the body. But it is not compressing only the one portion or the one surface. It is compressing total volume of the body. Clear? That is why this particular stress is termed out as volumetric stress. Got it? And it is defined as force per unit area. Okay? And whatever the area you will take here, it will come around here. Got it? Now, this force results in change in volume. As you can see, there is a decrease in volume. So ultimately, if you are inside the water, this is, let's say, water inside. This ball is inside of water. So what water will do? Water will apply the forces, normal forces to this body. And these forces are hydrostatic due to hydrostatic pressure. Okay? So sometime this volumetric stress is also called as hydrostatic stress. Hydrostatic stress. Got it? So ultimately we can define pressure as force per unit area. So this is a pressure force also. Okay? In case of a rounded object. But if you have an object like this and force is like applied like this, this force is also counted as a volumetric stress. This force will also produce a volumetric stress because it is trying to compress the body. Got it? So that is why hydrostatic pressure or the pressure developed due to the water inside, if the object is inside the water, that particular force also produces a volumetric stress. Okay. Now, shear stress. What is shear stress? देखो, we have applied the force perpendicularly. We have applied the force volume along a volume, throughout the volume. What if I apply the force tangentially to the surface of a body? This body, this particular cube has this surface area. If I apply a force like this, it will develop the longitudinal stress. Let's say this is F1. It will produce a longitudinal stress. And especially if I elaborate it more, it will produce so sorry guys, there is some interruption here from my end. Now you are able to see the screen. Okay. So shear stress के बारे में we are talking about. Shear stress I have defined as when you applied the force tangential to the surface. So that force per unit area gives you tangential force or tangential stress, which is termed as shear stress also. So in the same question, if it is saying that force applied perpendicular to ABFD, let's say this surface is ABCD. So force applied on ABCD, ABFC, perpendicular to ABFC will produce a longitudinal stress, and force applied tangentially to this surface will produce a tangential stress. Got it? Clear? So this is a tangential stress. It will try to change the shape of this body. The condition here is this left end, this bottom end will also fixed. Okay? If it is fixed, it will move like this. This is the angle, let's say theta. So this particular angle theta, and let's say this is the displacement from the original position, which is delta L. Okay. So force here will produce, it is given by, shear stress is given by tau. So tau here is force tangential per unit area. Got it? I hope this is clear to everyone. Is this clear to everyone? Any kind of doubt in this? So I have launched the poll. Please mention your attendance in this poll. Okay. And each try to answer each and every question. Please do participate in this poll so that I can take your attendance. Got it? So if anyone has any kind of doubt, you can ask. Otherwise, you can leave if you do not have any kind of doubt. Okay. Thank you so much for being attentive and being responsive. Bye bye. Take care of yourself.